Welcome to our channel. Let's revisit this newly appeared problem again. Select key disjoint special substrings. So in a previous video, we solved this problem using dynamic programming with the help of dictionary, right? So here I want to solve this problem using dictionary plus construction. Basically, we construct as many disjoint substrings as possible. So this solution here we're going to present is mainly based on this constraint or assumption. S consists only of lowercase English letters. And due to this fact, there are at most 26 unique characters in the string S, right? So this version here is a previous solution. I'm going to delete all those. So now what I want to do is still first we want to get the start and the count. And also notice that if a character is included in a special string, in a special substring, then all the occurrences of that character should be included. So here I also want to get a count function. So here I'm going to use collections counter, right? So then, as before, we're going to do an iteration for I, C in enumerate S. So in the last solution, what we did is that if C not in first, so we're going to set first to be I, right? And then no matter what, we want to, let me use first last and begin and end. First and last. So the last will be at C will be I. And because of this if check and this continuous update of character C in last, so the result will be the following. So we only record the first occurrence of a character, and also we continuously update this appearances of character. So the result in last will be the last indices. So this is the one way of writing this. So here actually we can also delete this two lines or comment out. So we can use this set default function. So we can set this for the key C and I. So if this C is already in the first or in the dictionary, so this line or this set default plays no effect. Otherwise, it will be set as the first occurrence. So essentially, these two lines and this line is equivalent, but this method set default is very elegant in a sense. So also I want to have a count of the character. So that's to be incremented by 1, right? So though for the count you can do this, you can do S, but this is the one more loop. But here we just use loop and augment all those things. So this is the one part corresponding to the first part of the previous video, right? So now what we want to do is we want to construct intervals. So the foundation or the observation we have is that at most 26 characters, unique characters, I mean, in S, right? So then we want to check if we can, for a index I and index J in the start and end, if we can use them as intervals. So we can do this, intervals. So basically we just iterate over for character 1 and the corresponding indices in first items, right? And notice that you need to write these items. And similarly for character 2 and the index, this is the end index, right? In last items. So what we want to do is to check if ij corresponds to a valid special substring in this problem, in the sense of the current problem. So it means that the I will be the start and the N will be the end of the boundaries. And all the characters in between, their ends and their ends will be less than or equal to J. And their starts will be greater than or equal to I, right? So then what we want to check is that first we need to make sure I is less than or equal to j, right? So when I equals to j, it means that it's possible to be a unique character, like the E and F in the example 1. So then the count of the, let me count the length, will be 0. Then we want to check for C in count, right? So then we can have the start and end of C. So first C, so it should be less than or equal to last C, right? So we want this to be less than or equal to J, and greater than or equal to I, right? So if this is the case, it means that all the occurrences of this character are in this within this boundary ij, right? So we are going to do length incremented by count c, right? So it might be good, to see so number in counts. So I'm going to use this as items. That may be better. So and characters, right? So this is the one. So after we do this check, so we need to make sure. So the length will be the potential interval length. So if I and j can be the two ends, then the length should be if length equals to j minus I plus 1. And also the length should be less than n, right? The length of this, let me do this. You can introduce this variable or not. Just here I introduced it just for convenience. So here length is less than n, meaning that for the substring starting from I ending at j, it's valid, and also it's not equal to the whole string. It's not the entire string. So if this is the case, so this is one I built. So we're going to intervals append this ij. So this finished building all the possible intervals. But here I want to get the maximum disjoint possible intervals or corresponding substrings as I like. So this basically is an iteration for ij in intervals, right? So here actually we can first sort that intervals. We can sort. So you can sort using a key. So you can sort maybe according to the start or according to the end. According to start from small to large, or you can sort according to the difference, right? The length of the interval. So basically, map item to be item 1 minus item 0. In other words, I want to make the small the intervals as many as possible. In other words, we can start from the shorter ones, right? So for this one, for this in intervals, then the start, we want the start and end to be ij, right? So this is the candidate. But also we want that the previous ones does not intersect with this this one. So what's the condition? So basically, if all intervals in before, so for x, y in result, the previous state. So for those intervals before, we want them to be disjoint with this ij. But because we didn't sort according to the start of the the end or the ends of the intervals, so this can be larger or smaller. So what the condition will be, that's me, y is the end, is larger, greater than or equal to, say y is less than I, strictly less than I. So in other words, this corresponding to this is the ij, right? So then y is smaller, so you're going to get something like this. So the ij is in the right. So or you have something like this, x, y. So x is greater than j, or x is greater than j. So for x, y in this result, previous state. So if this is the case, Then meaning that let's see, or let's see, we have this for x, y in result. Yeah, this should be right. Let's see. Yeah. So then in this case, we are going to append this ij to the result state. So each time, so actually we can do a return like this. So if the length of this result is greater than or equal to k, so this is the most verbose return. Let me first run it to see if it works. Yeah, it passes all the cases, test cases. Now let's look at the generic case. Yeah, it passes all the generic cases. So now let me first do some tweak here. So n substrings. So originally 0. So each time you do an append, the n substrings is incremented by 1, right? So here, what we want to do is originally is 0. Let's see. So it's possible to have zeros, right? K equals 0. And in this case, we can check, right? So if and we can do something like this at the very beginning even. If k equals 0, return true, right? And then here you do this. If n substrings equals k, return true. Otherwise, you can return false. This is also a valid coding. Let me check that. Can't access local variable and strings where it's not associated with value. Oh, I see here. So n substrings still, if n substrings is not defined as n substrings. So now let's run it. Yeah. Yeah, it passes all the cases. So, but in this case, we will not have the whole valuable results. So now let me recover the previous state. So let's not do this. It might be better copy this one, right? And then put it here, and then change this one to be version v1. And then we use the original version because it will print out all the constructed in substrings. So what we want to do is to do some prints. So here, the first and the last and the const, we have done such print in the previous video, so we are not going to repeat. So now I'm going to print out the intervals. Print out the intervals. So this actually corresponds to the second part in our previous video. Let's see what we have, right? So this is the interval. Start from 2 and end at 2. Let's see example 1, right? That is C, right? And also we can start from 2 and end at 3, or we can start at 3 and end at 3. This corresponding to D. So this corresponds E. This is the EF. This is the F, right? So similarly, you can look at example 2. So this start from 1 and ending at 2, 3, 4, right? Or you have 2, 2, so just the E. And 2, 3, that is the EF. And 3, 3 is 0, 1, 2, 3 is F, right? So let me print out the result. So let's use first example. So that's the intervals, right? Did I print out that? Let's see. Let me. Yeah, here. So we have returned, but let me modify this. I didn't modify, right? So have this one. So we don't need this substrings in this version. But here, let me first make sure it works. wrong answer. What's the problem? So here, this will be 1. So print intervals. So we cannot return false. We want to return the length of the result is greater than or equal to k. Let's submit. Yeah. So here we have print out this intervals, right? This is the one we construct according to start and end and expansion. And here, this is the maximum number of intervals we can build. So let's run it. Yeah. So if you look at, this is the example 1, I guess. So we can have 2, 2, that is C. We can have 3, 3, that is D, right? We can have EF corresponding to this 2 intervals. So if you look at case 2, so what we get actually is 2, 2 corresponding to E, and 3, 3 corresponds to F. And for this one, so no valid one, because always the entire string, so it's going to be empty. That's actually the red thing. So with that said, I guess that's the coding part for this problem. So it would be beneficial if you can compare the solution here and with the solution in the previous video. So in this one, actually, the main observation is that there are at most 26 unique characters in S, so which we can do it in a brute force but a clever way. So that's about it. Thank you for watching.